Next one I'm going to look at is 2014 C1, question 2b. So it's wanting you to give the Q and the P values there. So first of all, if we start off with our basic form of a quadratic graph is x squared. This graph has been moved across 2. So when I move it across 2, inside the brackets, so you do the opposite. So that's x minus 2 squared. So if you look there, my P is going to be minus 2. Now your graph has been turned upside down. So it's going to be, the next stage of that is turning upside down, is a 2. So that's minus x minus 2 squared. Now, I don't know where it crosses the y-axis, that from my wee sketch. So if I try on my equation here to put x equals 0, I get my y to be minus 2 squared is 4. And that's exactly the same as the graph there. So altogether, my graph was correct, minus x minus 2 squared. So the P value is inside the brackets, so P is minus 2. The Q value is outside, so it is minus 1. Now I have another 2 questions to do with this paper. The next one is 5a. And in 5a it's just completing the square, so it's not too hard. So question 5a. So first of all, you've got 2x squared minus 8x add 1. Before you complete the square, you must have it as x squared on its own. So you have to divide everything here by 2. To complete the square, half the middle one, so 4 becomes 2. Take the new number away squared and drop down the end. So it's 2x minus 2 squared minus 3.5. You can multiply that out if you want. So I would tend to do minus 7. So part B then says, hence state the minimum value of this and the value of x where it occurs. So if you just think back to your graphs, that's part 1, that's part 2. And if I try to sketch that, so you have got in here at the minute x squared. You move it forward 2. So x minus 2 squared. Timesing it by 2 just makes it a bit steeper. So it'll be something like this. And then minus 7 means I'm going to take that steeper graph and drop it down to minus 7. So that's 2 and minus 7. So the minimum value of that graph is minus 7, and it occurs when x equals 2. Now there's still one more question to do in this paper, and it's question 8. So again, towards the end of the paper, it's likely to be tricky. So question 8. Show that there's no value such that this line is a tangent to this curve. So I'm just going to write out these 2 equations. This is the line and this is the curve. Now, if it's a tangent, it touches the curve once. So basically, I'm talking about the intersection. So let's see about the intersection of these graphs. So you notice I just moved that so it was y equals, got y equals and y equals. Just set them equal to each other. So x squared minus kx minus 1. So if they meet each other at a tangent, it means they meet once. It means the discriminant should be 0. So let's see what the discriminant works out to be. So b squared is minus k squared, so it's k squared minus 4 times 1 times c. Now, I want that discriminant to be 0 for it to be a tangent. So it's k squared add 4 equals 0. So k squared is minus 4. So k is the square root of minus 4, which is impossible. So the curves don't meet. So they don't meet.